Hello viewers, welcome to Young Maths Academy. Today will be lecture 3 on longitude and latitude. As you can see on the board, we are to treat distance along parallel of latitudes. So the question says that find the distance between A 50 degree north, 94 degree west, and B 50 degree north, 86 degree east along the parallel of latitude. And also the II says that along a great circle. So we want to consider this today solution. So before I go into this question, I will want to tell you that the way we find distance along parallel of latitude and along a great circle are two different ways. So if you follow through the previous classes, you would have seen how we find distances or latitudes along parallel of along great circle. But today we have to discuss on how to obtain distance along parallel of latitude. First, if I have a sphere, the Earth as a sphere, we have something like this. This is north, south, east, west. We have the east-west axis. We have the polar axis, something like this. If I bring out a circle from this, suppose I have a circle this way, I have something like this. This is not just referring to that, so that I have something. This is the center of the circle, the center of the Earth. Let's say I have this, and I have this. So let this point be labeled L. Let this point be M. Let this be O. So we can call this is our R. Here we have theta. So here is theta. So here is R, the radius of the Earth. Okay, the radius of the Earth is the distance from the point in the circumference to the to the point of the circle, at the center of the circle, to a point in the circumference. Represents the 6,400, which is the radius of the Earth. Okay, so if I have this, I can give this also name. Let me say this is N. Good. So from here, you can see that if we consider the triangle LMO, let's consider the triangle LMO. Let us consider the triangle LMO. You can see that from this triangle, we can say that cos theta is a right angle triangle, this triangle. So cos theta is adjacent to hypotenuse. So the adjacent over the longest side of the hypotenuse here. Yeah, R. So means I have small r over capital R from there. So, and this simply means that R is the same thing as capital R cos theta. So in this case, we'll have to be applying this formula when we want to find radius of parallel lines, distance along parallel lines of latitude. We know that distance AB, suppose you have 2 points AB. The distance AB is theta over 360 times 2 pi r. So now it will be times 2 pi r cos theta in this case. So this is the formula that we'll use in calculating distance along parallel lines of latitude. Okay, very good. So just as you can see now, we can take this question. So we have that we have to find distance along these 2 points. So first is to get along the parallel lines of latitude. So from this that I drew, you can see that 50-degree N, that's the starting point. So 50-degree N, it's around there, something here, 50-degree N. And here, likewise, I have something, sorry, let's give this 2 point first. We have point A, 50-degree N, 94-degree west. Let's look for our 2 points along parallel lines of latitude. So I have to create parallel lines of latitude, a small circle. So let's the first point is west, 94-degree west. Means at this point I have this point west first. So here I have point A. Let this point be point A. So and then B, let this point be point B east. So 86 degrees, let this point be point B. Good. You know, the first thing is that we have to look for distance of AB. So we have to join AB. Then we always make reference to what? To the center of the circle, to the center of the Earth. So I have to draw this line this way, this line this way. So I am having something like this. So instead of drawing this line this way, we can make it a kind of arc. So it means I have something like this. So something this way. So that from here, this is the point A. So here is 50-degree, 50-degree north. So east towards the north. Then here is another 50-degree towards the north as well. Those are the starting points. So if it was 0 degree means we will be is our 0 degree equator at the center here. So but 50-degree, you have to create this like this. So that from here, if I bring out this diagram, I have something just like this. Something like this. And from this is B, this is A. So very good. Now we are to find distance along the parallel line of latitude, along the parallel of latitude. So we need to know the angular difference here. So to get the angular difference here, we have to consider that they are different directions. A 94-degree west and 86-degree west. So our angular difference theta will be the longitude A plus longitude B. That is, it will be 94-degree plus 86-degree, and our theta here we simply give us that is 180-degree, isn't it? So we have a 9486. So this is yes, 180. So that's 180-degree. So theta is 180-degree. So our angular difference here is 180-degree. So we can now find the distance by saying AB is theta by 360 times 2 pi pi r cos theta. So AB is equal to theta is 180-degree. That's the angular difference. 180-degree over 360-degree times 2 times 22/7 times 6,400. That's multiplied by cos. Theta here is 50-degree. So this particular theta is 50-degree. So that's at this point we have that. I have to rub this off. So I have AB is equal to 180. That's simply the same thing as 1/2 by 44/7 by 6,400 cos 50-degree. So this is same thing as AB to be 44 by 6,400 cos 50-degree all over 14. So our AB punch this in our calculator, we do have it to be 13, that is 13,000 kilometers. That's approximately 13,000 kilometers. So we have this to be 13,000 kilometers approximately. When you make use of your calculator to punch these values, you get approximately 13,000 kilometers. You should have 1292 9.5, but approximately to the nearest kilometer we have that to be 13,000 kilometers. Okay, so this is the distance along the parallel of latitude. So we are to obtain the distance along the great circle. Okay, so to obtain distance along the great circle, I will have to draw this again so you can see this properly. I have something just this way, something like this. You know, we have the polar axis and we have the east and west axis, north, south. Here we have 0 degree east, here is west. Okay, from here, so we said when we drew our 2 points, we had something like this, and then this was point A here, this was point B here. We trace this onto the center, something like this, yeah, something like this. So here we have 50 degree, here also 50 degree. So quickly, we want to get the distance along the great circle. The angular difference will be different to get the distance along the great circle, because we are talking about the distance along this great circle. So the distance of AB, along the great circle. So if this is 50 degree, we know that from our knowledge on parallel lines, we know that angle in a straight line is 180 degrees. So if this is 50 and this is likewise 50 degrees, so it implies that my theta here, my angular difference, will be 180 degree minus 50 degree plus 50 degree, so for me to get the angle here. So, and then and that will give us 80 degree, because that's 180 minus 100. So the angle here, the angular difference here will be, so our angular difference regarding great circle, distance along a great circle, is 80 degree. So if that is like that, so we can now obtain the distance of AB along the great circle, so that we have that to be. So the distance along the great circle has a different formula, so we don't have to include cos theta. So that is, it is just simply theta by 360 degree times 2 pi r. So we did something like similar in previous lectures. So that this is AB is equal to theta is 80 degree, 360 degree by 2 by 22 over 7, 6,400. So AB is this is something else. This is let's just say 80 by 44 by 6,400 7 by 360. So when we punch this in our calculator, we do have our 8,940 kilometers, that is 8,940 kilometers. So we have 8,940 kilometers approximately. When you punch this, you have this. So we can see that. And this is how we solve questions to get distance along parallel of latitude and great circle. And then you could observe that in our first class we talked about that distance along a great circle is shorter to distance along parallel of latitude, which is correct. This is distance along a great circle, and distance along parallel of latitude, we add that to be 13,000 kilometers. So it is easy to say that it is clear that 8,940 kilometers is lesser than 13,000 kilometers. Thank you.